Find the arc length of the curve given by the vectored valued function r of t over the closed interval from 1 to 4. Let's first take a look at this graphically. The space curve given by r of t is graphed in purple. I also included the trace vectors at t equals 1 and t equals 4. This indicates we're determining the arc length between these two black points, or the terminal points of the trace vectors. Not the most exciting graph, but this is the arc length that we're finding. And now going back to our work, we have our arc length formula below, where the arc length s is equal to the integral from a to b of the magnitude of r prime of t dt, which is equal to the integral here on the right. To begin, looking at the vectored valued function r of t, x of t equals negative 4 t to the 3 halves minus 1, y of t is equal to 2 t to the 3 halves minus 6, and z of t equals negative 2t plus 3. And now to determine the derivatives, x prime of t is equal to negative 4 times 3 halves times t to the power of 3 halves minus 1 minus 0. Simplifying, we have x prime of t equals negative 6 t to the 1 half. Y prime of t is equal to 2 times 3 halves times t to the power of 3 halves minus 1 minus 0. Again, simplifying, we have y prime of t equals 3 t to the 1 half. And then for z of t, z prime of t equals negative 2 times 1 plus 0, z prime of t equals negative 2. And now we have the information we need to set up the integral, where the arc length s equals the integral from 1 to 4 of the square root of the sum of the squares of the derivatives, which gives us the square root of the sum of the square of negative 6 t to the 1 half, the square of 3 t to the 1 half, and the square of negative 2. Simplifying, the square of negative 6 t to the 1 half is equal to 36t. The square of 3 t to the 1 half is equal to 9t. And of course, the square of negative 2 is 4. Simplifying and writing the square root using the rational exponent of 1 half, we have the integral from 1 to 4 of the quantity 45t plus 4 to the power of 1 half dt. To integrate, we need to perform u substitution, where u equals 45t plus 4, which indicates du is equal to 45 dt. Solving for dt, we divide both sides by 45. We have 1/45 du equals dt. And now let's write the integral with respect to u. And because 1 and 4 are t values, we will leave off the limits of integration. dt is equal to 1/45 du, and 45t plus 4 is equal to u, giving us the integral of 1/45 u to the 1 half du. Integrating, we have 1/45 times u to the power of 3 halves. Instead of dividing by 3 halves, notice I multiplied by 2/3, and then we have plus c, because we have an indefinite integral with respect to u. Simplifying, we have 2 divided by 135 u to the 3 halves plus c, which means with respect to t, the antiderivative is 2 divided by 135 times the quantity 45t plus 4 to the 3 halves. For the next step, let's go ahead and factor out the 2 divided by 135. And now we perform the substitution. When t equals 4, we have 45 times 4 plus 4 to the power of 3 halves, which is 184 to the 3 halves. And then when t is 1, we have 49 to the 3 halves. This gives us 2 divided by 135 times the difference of 184 to the 3 halves and 49 to the 3 halves. To simplify, remember 3 halves is equal to 1 plus 1 half, and an exponent of 1 half is equivalent to a square root, which means we can write 184 to the 3 halves as 184 times the square root of 184, and we can write 49 to the 3 halves as 49 times the square root of 49. And now let's simplify the square roots. The square root of 184 is equal to 2 times the square root of 46, and of course the square root of 49 is equal to 7. 184 times 2 square root 46 equals 368 square root 46, and 49 times 7 is equal to 343. So the exact value of the arc length is 2 divided by 135 times the difference of 368 square root 46 and 343, which is a decimal, is approximately 31.8948. I hope you found this helpful.